Hi, I'm privileged to launch our new product that is Automotive Communication Unit under our Decibels Lab's Lab Business vertical. This product has been designed to address the learning needs of our latest communication protocols. In automotive, there has been a lot of evolution with several number of electronics coming in. We call as ECUs. So all of them need to be communicating with each other over specific type of protocols. The CAN has been the predominant type of protocol that has been used in automotive. This product is designed to make you get a full-fledged, hands-on, practical learning experience to build a complete confidence to work with CAN communication protocols. This product has two sides on the panel, and one side is to learn on the most foundational layer, and the other side is to learn integration of several number of components together like a car. To make your learning experience much more hands-on and practical, we have customized and developed this side of the setup. To give you a quick overview what is there in the hardware, so we have a CAN training control panel, and then we have a CAN training cardboard. The CAN training control panel is like a switches and a buttons in your car. If you want to turn on a headlight, you press a button, indicators, or it could be compressors or any other components like that. So this has several variety of input signals, and to correspond to that input signal, we have the hardware board where we have several output components. Let's say you turn on a headlight, so the lights are going to turn on. The same way, here we have a setup which can replicate that. This is just a physical interpretation of the CAN messages as a button going to the ECU, and the ECU sending the CAN communication messages over this yellow-green line, and then it comes here, received as a CAN message, and that is triggering specific component of the hardware to turn on and turn off. To get a complete idea and understanding of this whole setup, so we have an oscilloscope. With the help of oscilloscope, you can probe the system and see how the frames are going to come in. It gives the complete clarity for a student. If I send a bit through the CAN, how does it look through over my CAN frame? In addition to this, we also have a logic analyzer, which gives a more clear understanding of each and every parameter of the CAN frame. And then in continuation to that, we also have our logic CAN analyzer. The CAN analyzer device, which can be used to decode the messages on the bus or to see the messages on the bus. So the whole CAN data which is going through this network can be analyzed through our CAN analyzer, and it will have a GUI screen where you can see the CAN frames coming out as information. To give a quick, swift idea of this whole setup, let me go on the other side. So imagine this setup is like your interface of the car. It could be a touchscreen, it could be buttons and tactiles and anything of that sort. Let's say all of these buttons are being interfaced to several of these outputs, right? So if you take any of these buttons, let's say this button is interfaced with maybe a parking light as an example. This is interfaced with maybe a low beam. This is interfaced with possibly rear indicator systems and things, or parking lights in place. So several of these are interfaced with any of these outputs signals. Similarly, we have like high beams, and several of these pins are assigned, and then we have the rotary options which can give the inputs to a variety of components in place, and then we have sliders where the data can turn on the compressors and HVAC systems and blowers and things like that. So what makes it possible to learn, right? So first and foremost thing, you can pass a one bit and see through the oscilloscope and see through the bit analyzer, get a deeper understanding of how CAN frames are being sent, so how the protocols are working in nature. On top of this, with the help of this CAN analyzer which we have here, we can see the assigned CAN IDs for each and every output components. On top of all of this physical hardware which is present here, we have developed a very comprehensive outline manual which lets you to conduct several number of experiments on top of the setup. So in a way, this portion of the setup would help you to build a solid learning experience to begin with a very basic layer of CAN. And then we build an understanding to go on to the other side, which gives you a full-fledged exposure to build a CAN matrices and creating DBC files to decode the information that is going through the bus in place. On the opposite side of the Automotive Communication Unit, we have all the vehicle components here. So vehicle components such as our battery with the battery management system, motor controller, current sensor, HMI. We also have our charger. So if you consider it like an application perspective, it is like all the vehicle components, and each of this component would be acting as a node in a vehicle. So the BMS may be sending the data to a VCU or an ECU. The motor controller is also sending the data to an ECU or a VCU, or the current sensor, HMI. All of these are working as individual nodes in a vehicle level. If we take an example of the battery management system, it will be using the data such as the battery voltages, the cell voltages, the temperatures, the current, and maybe the fault conditions, a variety of inputs via the CAN communication protocol to any other component. The same way, if you take the motor controller, it will be sending the data via information such as the motor speed, the throttle percentage, the Hall fault, or any such variety of information that is needed by any vehicle components will be sent by the motor controller via CAN communication protocol. In such way, maybe the current sensor and also an HMI will be also working as individual nodes where they'll be able to send the data, or possibly they'll be able to receive the data and display the information. So what is the objective of this side of the learning kit? It is that once the learner builds the foundational understanding on how to work with CAN messages, CAN frames, decoding the CAN frames, they come here, work at slightly a more complex level in creating the DBC files and implementing the DBC files to decode the CAN frames that is coming from each of these components in place. So in this process, the learners apply their learning knowledge that they have gained in the opposite side of the kit and get to create the DBC files with the help of the software tools that we will be providing to the learner. And the input to this will be going to the data sheets of our hardwares that we have used in this opposite side of the kit. And then that DBC files will be implemented over the software that is called CAN Analyzer software, so that the information from the BMS is coming via as a CAN IDs with the CAN frames, but they can be decoded into a readable and a measurable values via the HMI screen that is visible to you over there. So with the whole learning possibility as a part of the kit, the learner learned the foundational knowledge on the opposite side of the kit and then get to apply the learning to decode the messages which is running over a CAN bus on this side of the setup. In this way, the learner will be able to apply the learning skills and then build a complete confidence to work with any of the practical hardware setups which are in the vehicle lab. The kit having both the sides, the importance is of the productivity. That means the facility of the training can be utilized in both the sides, and the trainer can teach more number of participants at the same time, and the learners can actually interact with each of these node components separately, and also can connect their laptops and components to write the DBC file and implement DBC files. In this way, the whole setup makes sure that you learn the foundational knowledge and also you apply the knowledge to work on any of these ready products which are in the real world, so that you gain that experience that becomes matter for you in applying for the professional skills. Thank you.